Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at what goes up involving rockets, hailstones, and engagement. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm super excited tonight to be joined by our two panelists, Adam Pennell and Julie Riggins. Adam received his undergraduate degree from the University of North Carolina and completed his PhD in mathematics at North Carolina State University. Adam taught for 3 years at Bluefield College and has spent the last 20 years teaching at Greensboro College. When Adam's not teaching, he enjoys spending time with his wife and son. Janet and Adam have been married for 26 years, and their son is 8. Adam, thanks so much for being with us tonight.
Well, thank you. Looking forward to talking, and hopefully not sounding stupid. But anyhow, go ahead.
And Julie has been teaching high school math for 24 years and loves the challenge of helping students appreciate the math that is around them by analyzing a tossed ball, a rolling car, or a launching rocket. Julie wants students to be curious, to ask why, to be creative, and discover relationships. Julie is a 2013 Presidential Awardee for Excellence in Math and Science Teaching, as well as a National Board Certified Teacher. Julie, thanks so much for joining us tonight.
Thanks a lot, Mike. I'm happy to be here.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send questions to Adam or Julie using the Q&A window on the right side of your screen. We'll be using the chat window tonight to send general messages. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, try selecting Communicate in the WebEx menu and choose Audio Broadcast. At this point, Julie is going to discuss our agenda.
Okay, thanks. So we've already done our welcome and introductions. We're going to do 2 activities tonight. Our first activity will be about launching a rocket, and I'm going to share how to build rockets and collect data and show you how I model the data with a piecewise function in my Math 1 class. Our second activity, Adam is going to share with you coding the hailstone sequence. He's going to introduce to you the hailstone sequence and share how to introduce coding in the classroom and demonstrate coding the hailstone sequence.
Thanks so much, Julie. And Adam is going to discuss our expected outcomes for tonight.
Here's what we hope. We hope after you finish listening to our webinar that you'll be able to have the essentials to build and launch the rockets. We're going to hope you can analyze the data and build functions that model it. We're not going to be using regression as we do this. We're going to take the data and sort of think our way through it, or more accurately, Julie is. We're going to create, she's going to create a piecewise function that models that data using I-84. Now, when I get my term up the bat and I start talking about the hailstone sequence, I'm going to explain what it is and what makes it interesting. I hope after you finish all this, you'll understand how to code the hailstone sequence using either the TI-Nspire or the Nspire. I'm going to kind of bounce back and forth between both platforms. And I believe you'll have the tools if you want to use the hailstone sequence to introduce coding in your own classroom. All right, those are our outcomes.
Thanks so much, Adam. So Adam will give you control, but I know Julie, you're up first, so feel free to share your screen, Adam and Julie, whenever you're ready.
Okay. So a goal I have in teaching, as we've said already, is to provide opportunities for my students to appreciate the math that is around us every day. When we math teachers see a home run, I mean, don't we think about velocity and angles? And I want my students to think about these things too. I do hands-on data collection and experiments to make the math more real and applicable to everyday life. So one activity that I do is to build and launch rockets. I order my my rockets from a company on the internet called Apogee Components. And this is my last, I was able to get a grant through North Carolina Council of Teachers of Mathematics to get 25 rockets, an altimeter, and 48 motors. You'll notice in this order that I got 2 packs of A motors. I think if I were to do this again, I would get some A motors and some B motors. The A motors obviously don't go quite as high, which is good if you don't want to lose an altimeter, but the B motors give better data. So I think having a good combination of both is good. And a first-timer, if this is your first time launching rockets, you would need a launch system, which is about $25. I let my students build the rockets, and my class period is 90 minutes, and I take 2 half days to build the rockets. So, and I only do 2 or 3 per class. If I had more money, I'd let everybody build a rocket. But they work in groups, and the first day they'll assemble the motor mount, and they will glue the fins on the rocket. And then the second day, after the glue is dried, they'll re-glue the fins, and they'll also assemble the parachute so that then after that second day, it's pretty much ready to go. So it really doesn't take a long time for them to build the rockets, and they take more ownership in the activity. So when there's good weather, now you got to have little to no wind to launch the rockets. If there's a lot of wind and you've got a good parachute, your rocket could end up on the cafeteria, on I-40, or in a tree. And not that those have all happened to me. Yeah, they have. So here's an example of our rocket. And I don't think you can hear the audio, but the kids are screaming. And you see one girl falling down there. It's really exciting to watch the rocket launch, and the kids have a really good time with that. Once the rocket lands, the one thing I love about this altimeter is that there's an app that goes with it. So when the rocket lands, it connects to my app. So while we're still out on the football field or the softball field or wherever we launch that day, I get data. I get the picture of the data on my iPad. So I know right away if I have good data or if the launch, maybe the altimeter has some gaps in it or something, which doesn't normally happen. But I know right away whether I have good data and if I can launch again. The rockets, you can usually launch them 2 or 3 times. And so we'll probably launch 6 to 9 times during a class period while we're outside collecting data. Then once we get back to the classroom, I email the data to myself. I open it in Excel. Now, if you are using the Nspire, you could just copy the data and paste it right into a list and spreadsheet page. We're going to be using the 84 tonight. And so I would save the 2 lists as a CSV file and send it to the calculators through TI-Connect. And I should probably give a shout out to the TQ people that were at NCTM last week because they helped me do this and get it into my emulator. All right, so we're going to go to the emulator now, and I'll show you my data. So you can see that the altimeter collects data every 500ths of a second. So there's a lot of data here, probably 400 pieces of data. And so we're going to see what the graph looks like. So we'll turn our stat plot on. And I'm going to use this marker. And I'm going to use the color red. Okay. And so now I'm going to graph it. So there's our data. Now, a lot of times in my classroom, I'll have the students set up the window because we know how high the rocket went based on, what we got on that app. But I'm going to go to Zoom and 9 just for sake of time. So Zoom 9, and there's our rocket data. I'll tell you, I've done this a lot over several years, and I'll tell you, every time I see it, I'm like, wow, that is so pretty. Okay, so once we get this, yes.
Just got a question from Diana. Just wondering if there's a set of pre-activity questions that you or the students posted before you began.
That's a good question. When I first started doing this, I think I would say no to that. But now I do a couple of data collection activities that lead up to this. This is kind of the culminating activity. Notice how the parachute is what makes that linear, and I do parachuting Lego men with my students, and so they've seen linear data like this. So that helps them as they're thinking about how to model this. I hope that answers the question. Okay, so what you can do, what I'm going to do, when I go back to my classroom and we've got this data, I will screenshot this and give it to all the students because I like them to have a piece of paper so that they can sketch. They can sketch the functions on there. They can do their math, their calculations on the paper. And so I wanted to show you, just in case you didn't know how to do this, I'm going to actually take this and drop it into PowerPoint, but you can drop this into Word. And if you grab, notice I've just grabbed anywhere on this screen, and it picks up the image, and I'm going to take it to, let's see, I got to do it like this. Sorry. Let me go back and get it again. I can take it here, and I can drop it. And so we'll have a discussion about what type of function do you see here. Eventually we'll discuss that, well, maybe there's two functions here. I see a parabola, I see a line. So once we decide on that, then we will we'll talk about, well, how are we going to, how could we sketch the parabola? What would a parabola look like? Now, this is going to depend on what your curriculum does for quadratics. My curriculum in Math 1 in North Carolina, we need to relate the zeros of a quadratic to the function, to the the factored form of a quadratic equation. So my students are going to be focused on the zeros. And so if you look here, and I would have played around with this a little bit at home kind of to see what it is, but all the students have their data. So they can think about, I do see a question about how old my Math 1 students are, and mine are 9th graders. So these are 9th graders taking Math 1. And the, okay, I'm not drawing. I'm trying drawing, sorry. So we would start, we might decide as a class that we would have a 0, maybe not at 0, and they could try having a 0 at 0, but really like 0.3 is going to work pretty good for our data. So we're going to have 0.3 as a 0, and then we're going to go up here. And the vertex, so we could talk about the vertex. The vertex happens at 5, and so we have a nice little discussion about, well, parabolas should be symmetric. So if I've got 1 0 at 0.3 and the vertex is at 5, then I probably have another 0 there at about 9.7. So I would want them to kind of sketch this parabola on their paper. And then we're going to go to back to our data, and we're going to graph it. So what's going to happen is we'll say, okay, so we're going to graph this. So we're going to have x minus 0.3 and x minus 9.7. And we're going to hit graph and see what it looks like. Oh, and then my kids will say, wait, we got to turn it upside down. We got to turn it upside down. So we have a discussion. We're going to turn it upside down. And we'll insert a negative. We'll look at our graph. And the kids are pretty happy. Yeah, it turned upside down, but, you know, oh, maybe we need to stretch it. Maybe we need to stretch it. And so the students will play around with putting a coefficient in front there. And this is where the B motors really work better than the A motors. When I use a B motor, I usually get really close to a leading coefficient of -16 almost every time with this data. And that -16 is our gravity in feet per second. Isn't that nice? Okay, so we have a good parabola there. So now we want to go to the second part of our function, which is going to be our line. Now there's two ways that I would do this. One, and I think it depends on where you are in your class. I'm going to use this activity really as a review for quadratics and linear that we've already learned. We've already learned everything about quadratics, everything about linear, so I'm trying to make this real world application of this. But before my exam, I want my students to kind of refresh their memory. How do you find the slope? So, so we are going to trace the plot, and we're going to pick 2 points on our scatter plot. And I'm going to choose the 2 points I'm going to choose, just so it's easier to remember, and I need to tell you what they are instead of tracing it, is 10 and 244. And maybe you'll just believe me. So it's 10 and 244, and 5 and 128. And I'm just going to go to the calculator page and do that. With the 84, remember you can do alpha and y equals, and that gives you the fraction template. So I'm going to use the fraction template, and I'm going to do my 2 points. My y values were 128 minus 244. And my change in time there was 5. I went from 10 seconds to 5 seconds. And when you hit enter, the calculator, the mode is set to do automatic. But I wanted to share with you that if you arrow up and enter on your slope and you put a decimal in your slope, if you put a decimal anywhere in the problem, that tells the calculator, hey, I want a decimal instead of a fraction. So we talk about this -23 and what that represents. So that's how fast our rocket was falling to the Earth, at -23 feet per second. Then if I wanted to calculate the y-intercept, if I use the point 10 and 244, then I would take my y value, 244, and subtract the slope. I'm just going to go up and enter to bring that down, times my point 10, and enter. So there's my y-intercept. So I have a slope and y-intercept, and I could go to y2 and put that in there. But I want to show you another way as well. So I'm going to go back to graph. And Adam mentioned earlier that we're not going to use regression. That's kind of like a challenge of mine, is to try to model data without regression. I want students to understand what the coefficients and how the functions are working, not to just push buttons on their calculator. But if you go to where regression lives, so regression lives in Stat Calc, if you go there and go to the bottom, there's manual fit. So if we are going to manually fit a line. We're going to store that into y2. So I went to variables, y variables, function. We're going to put that in y2. And notice what it's telling me to do. It's telling me to drop points. So I'm going to bring this cursor over here and try to choose 2 points there and maybe there. Okay, so I'm manually fitting that. That's not too bad. And if I hit enter, notice at the top, so there's my slope. So the line that I have fit, I don't know if I like that very much. It seems to be a little too steep. And notice that's got negative 24. If you hit enter right here, you can change that negative 24. I'm going to put in negative 23 just to see what it does. And I'm going to hit enter. Okay, and it also got my my y-intercept a little big, a little too large as well. So, but you can change them. That's what I like about this. So it fit a pretty good line to it, but you can change it if you want to. I'm going to go with 480 and see if I think it was 476 or something, but we'll see if that's better. So notice there's a done here. So that's a soft key for graph. So we're going to say done, and it has saved that equation into y2. All right, so now we are ready to graph a piecewise function of our data. Let's go back and look at this graph for a second. So there's a good discussion that would happen, and I think Adam and I did this activity with teachers, and it was interesting where they broke or where they chose to start one function and stop the other one. Some started at the vertex. I would think it would be more, you know, a little past the vertex where the rocket falls and then the parachute deploys. So we would have a discussion, and or the students could just choose whatever point they want to split the function and then see what happens. That's what's so great about the technology, is that they could choose the domain to be whatever they want it to be, and they get that feedback. If they're right, it's going to look good. If they're wrong, you're going to have this big break in your function. Okay, so we're going to break this around 6 seconds. So I'm going to go back to y equals. I'm going to turn off my function. So I'm going to turn off y1 by entering on the equal sign. Now piecewise in the 84, if you go to math, and I'm going to arrow up to get to the bottom of the math list, and there's piecewise. And I'm going to have 2 pieces. And I'm going to use my variables to pull back y1 and y2. So I'm going to go to variables, y variables, function, y1, and you have to put of x. So we're going to do y1 of x, and we are going to graph that for x's that are less than or equal to, oops. There we go. So that's second math for less than or equal to 6. Okay. Then we're going to go back to variables and pull up y2. Now this one, the 83s and 84s used to not do compound inequalities. So I'm so excited that it does this. So I'm going to do, this is going to go from 6 less than x less than or equal to, and it's about 20. The rockets stay in the air about 20 seconds. So I think that should do it. So this is going to be x is less than 6. So let's see if it works. So we're going to go to graph. And there it is. So you can see the quadratic being less than 6, and then the linear going from 6 to 20. So I'm going to come back to this and wrap it up. So this is a fun activity that I use at the end of the year, and it helps me review quadratic functions, linear functions, and it's really a nice discussion of practical domain when you throw in that piecewise function in there. And my big goal is that they have an appreciation of math in the real world. So I'm going to, that's the end for rockets, and I'm going to turn it over to Adam for coding the Hailstone sequence.
All right, give us just a second to change over because we're using the same computer here. All right. We don't need that, and we need to real quickly load a different, assuming it wants to do this, thank you. Load a different emulator state for, and I want Hailstone. Yes, I really want to do that. Talking to the computer really helps. All right, so shrink that down and don't close it. Okay, we'll just shrink the whole thing for right now, I guess. All right. Julie did a really good job. And by the way, I will say that I've had the opportunity to do her activity within the last 2 weeks in my classes, and it really does make for a very nice discussion as you go through a good review for the end of the year. Also got a chance to do the coding the Hailstone sequence, and I guess that's what I've been called up here to do. So I'll get started with this. Coding the Hailstone sequence, I guess before I really get started, I do like to give credit where credit is due. I got this introduction, and actually Julie and I originally put something together for a workshop we were doing, and we adapted the activity from the work of Joe Bowler. Now, she didn't do coding with it, but her treatment of this is actually quite wonderful. And there's the link, but you can pretty much just go to her uCubed site, should be able to search Hailstone, and you can see how she handled it. All right, so let's get started with kind of how I approach this in my classroom. What we have up here on the screen right now is the top of a handout that I give to my students. And really from this part, all I want them to do is realize what makes Hailstones really interesting, beyond the fact that it's kind of a cool sequence, is that it's an unsolved problem in math. And I'll explain to you what I mean by that as we go along a little bit. But what makes that interesting is there's actually something to investigate. People don't know exactly how these behave. They have a good guess, but they're not sure. Now, at the bottom of this screen is a little example of the Hailstone sequence, 20, 10, 5, 16, 8, 4, 2, 1. Now, for right now, the main thing about that is the reason it's called Hailstone is it goes up and down. Now, how the sequence is generated, it's an iterative sequence. You start with a positive integer, or like I said there, an integer greater than 0, but whatever. If the number you pick is even, you divide by 2. If it's odd, you multiply by 3 and add 1. At this point, after I've had the students read this and we've talked about it, what I want them to do is, okay, pick a number, well, positive integer, and go out with it. See what happens, because I want them to just investigate. Now, if we were all in the same room, I would have you do this too, but make for a really kind of tragic webinar. So instead, I wrote a little program on the Nspire, and here it is. It's got my silly cow on there. If I had more time, I'd explain where the silly cow came from, but that's okay. But it's a simulation of the Hailstone sequence. All right, for the simulation, as we start our students working on this, some of them are going to be lucky and pick a number like 12. 12 is a good number because the sequence is not going to run that long. Now you can see it running kind of here while I'm talking. With this number, what I want them to do as they're playing with this is first just get a feel for how the Hailstone sequence works. Now, obviously, that's not going to take long because dividing by 2 and multiplying by 3 and adding 1 are not terribly difficult. But I also want them to think about, where do I want to end this sequence? Because I don't want to keep doing this sequence forever. And you'll see in just a second where it's going to end, or at least where I have this program terminating, is at 1. And it'll tell you, here my little program says it took 9 iterations to go from 12 to 1. And I found students really fairly quickly figured out, because either They stopped at 1 just because the example I gave them on the last page stopped at 1, which is not really the reason I won't. But more likely, and what I'm hoping for, is they stopped at 1 because after they got 1, they multiplied by 3, added 1, got 4, divided by 2, 2, divided by 2, 1, 4, 2, 1, 4, 2, 1, and they figure out that 1 was a pretty good place to stop. And this is actually the part that's kind of a question, and that is, does it work this way for every sequence? Now, some of your students aren't quite as lucky, because if we reset this, and we could put any number in here. I think I limited it to 8 numbers, but we're not going to go that far. 55 is sufficient. And some of them will get this. Now, it'll just start like before. Now, being impatient, I put the show button in here so that it would stop this thing from running. Well, stop the equations from showing, and it'll go a little bit faster. And you can see that this sequence is a tad bit longer. And really, for the students to do this, I want them to get 2 things out of this. First, well, actually, I want them to get one thing, and as a teacher, I want y'all to get this out of it. I want them to get, I don't want to do this a lot. I want them to say, if I'm really going to investigate the Hailstone sequence, I can't sit here and do this 112 iterations. And I use this to justify the fact that I want to do a program to find the Hailstone sequence. I ran this for y'all to emphasize you don't want to do this all day. Pick like 10 minutes and stop. Because part of the class will have gotten to 1, some of them have gotten to 1 a couple times a different sequence. Others will still be going. But you've made your point at that point. We've justified the fact that we need that we want to use a program, and they know something about the Hailstone sequence. And so then we go from there. All right, so let me return to this. Now, as I do this, I thought it'd be a good time to stop and say, well, kind of keep going, but anyhow, why do we want to introduce program with the Hailstone sequence? To me, it's 2 things, and I'll just say them real quickly. First, all the basics of programming are covered. As you go through this, I've set it up as an introduction and 3 tasks. There's a 4th task that's optional, but through those 3 tasks, you would do display information, request information, conditional statement, and loops. That's a pretty good introduction to programming. Plus, if you do the optional one, that adds a list. Now, we won't get to list tonight. We just don't have the time. But it's a nice addition, and it's really good with the program. All right, but now we got this. Let's get started with how I would do the program. For the program, now I've given them a worksheet. And by the way, this worksheet, I created 2 of them, one for the Nspire and one for the 84. And it's like a 4-page worksheet, and it's going to be, we sent these to Mike, and he'll post them online. So if you want them, you can go in there and get them, and feel free to use them. But in both of these, all I'm trying to do is I kind of explain how you start the program and give them a little program. Now, there's enough information for them to do this part on their own, but really at the beginning, I don't want them to do this on their own, because what I want to do is I want to first make sure they're comfortable opening a program, the program editor, if it's Nspire, the page they need to, starting a document, all that stuff. And if it's and I want them to know where the commands are, and I want them to know how to run the program. So this first part I do together with the class, but I have the information there, so it's all listed out. Now the second page is right below what I just had up there. And again, you would either have the 84 or the Nspire, but all I'm wanting them to do for this first part of the program is assign a variable to 0 and then display the value of that variable. Now let's look at this, and I will start with the Nspire, and I'm going to bounce back and forth between the 2 of these. And let's see, go over here. Not much going on in the code. I mean, I've assigned a variable here. I guess really the only thing to point out there, I personally like using := to assign variables inside the program for the Nspire. But you can use, if you like the store works just like it does in the 84, and you certainly can use that. And then we have the basic structure of display. You have display, you have a just some text that you can send to the person, well, basically that you can display, comma, the number. Now the nice thing is the 84 code really looks pretty much like this. And you can make it look exactly like this. So let me go ahead and go over to the 84. And let's see. Oh, it helps if I don't have the erase button pushed. Program, and this one's called Hail. Oh, rats, I don't want to execute it. You know, I practiced this so I wouldn't do stuff like that, but all right, here it is. Now I know there's two display statements. There's a purpose for that. But first, here's where the 84 would assign a variable, and we're just 0 store in, and the store button is right here. And then we have the display statements. Now, that first statement is exactly like the one that you saw for the Nspire. I just don't happen to like it. And I don't like the way it displays, so I have the one below that. All this one below it is it has the one additional term. Obviously, we got a plus, but we got eval. What eval does is it takes whatever's inside those parentheses beside it, evaluates it. So in this case, it says, oh, n is equal to 0. And then it turns it into a string. And then once it turns it into a string, the little plus kind of hooks the two in strings, just the part in the quotes, hooks them together. So let me run this. And I can show you the two displays, and then we'll go on from there. All right, and so there are two displays. I do not like the distance that has there. And this is the second display. It's kind of hooked a little bit together. It's not a big deal. That's personal preference. But if you look at the codes that I have in here, and those codes are also part of the files that I sent to, the program's part of the files I sent to Mike. So if you want to look at them, you can go back and look at each of these. Now, from there, well, let's go back to one little display here. And I think an important thing to do after you've done these two programs is to tell your students, congratulations. You may not think of it this way. We think of it as building a big program. But for anybody who hadn't programmed, you need to stop and say, hey, you just wrote a program. And you know, I know it doesn't do much, but it is a building block to what we're trying to accomplish. And you can say, look, you now have written a program and you're a programmer. This is also not a bad moment to stop and tell students that this is also the way that we're approaching it in this the handout, the way programmers create programs. They don't just come up and write a giant program all at once. What they do is get one piece to work, add another piece to it, add another piece, and keep adding pieces until it does what they want it to do. All right. Now at this point, I think you get to the point where you really want to kind of, at least to as large a degree as you can, let the students go. And let them go and try, well, short version, not to help too much. And here's a quick point I want to make, so a little soapbox, I suppose. When you're doing programming, when you're doing coding, allowing the students to struggle is very important. Now, not that you should just sit them over there and watch them suffer, but when I say that, I'm saying that we need to, as teachers, take a moment and think about how we're going to give them hints so that we don't give them too much. We want to give them a nudge, not tell them what it goes, because we do not want to steal their opportunity to understand coding by telling them what's going on. And also, if we tell them how to do it, they might come up with some creative way to code something because they've never coded and they don't know what they're supposed to do. They might find a creative way to make something work that we'd never have thought of. Okay, end of soapbox. Back to what we're doing, which would be, like I said, this is set up as 3 tasks, and I now have this more pushed out to my students, and I come to task 1. All right, what I want to do as I do this is I ask the students, what is the first thing you did when you started the sequence? What I want them to think about, now this one kind of gives it away, but is the first thing they did is they picked a number. So as they're writing the program, they want the person using the program to also be able to pick a number. So we want to, see, here's the big hint. The hint is over the top, but I made it that way on purpose because this is the first task and I want them to do it by itself. I want to make it a fairly gentle step. Because it says you need to input, now for the 84 it would say you need to input information from the user. I'm not even sure that's a good sentence, but that's fine. Or, you know, for the Nspire it says you need to request the information from the user. So if we go and look at the code, and I'm going to switch now for the 84 over into the TI-Connect just because it's easier for me to bounce between programs since we kind of have limited time. And you can see all I've done right here. So we just added this one little command in, like I said, input. And if you look, and I sort of jumped the gun on one thing, but that's okay. This is what I would have if they went to, went and looked through the handout. They have this display. So like for the 84 user, like I was just showing, they would have input right here, and we'd have an example of how to use it. I do want to mention, be ready for this. Last time I did this, and it was a fairly sharp class. Actually, they were extraordinarily sharp. But I went around as they were programming this, and a whole lot of them had, what is your age, comma age. And there's even, in the handout, there's then request string, and it said, what is your name, comma name. And you just have to bite your tongue not to say, why are you asking the person the name? So that's why I have now added, these are examples to show you the structure, but not part of the program. So just warning, think about how you're going to handle that. But anyhow, back kind of to the code. And I suppose I was on the 84, but still I think I've said everything I need to with the 84, except for the fact that maybe I'm too lazy. I didn't even write out the word integer, but oh well. Now, the Nspire, you'll see the code looks pretty much the same. And we'll go to Hell 1 because this is task 1. Okay. The only difference is here we have the word request in here. Everything else is lined up exactly the same. Again, something for you to think about. When I say give them a nudge, be aware that it seems obvious if you've programmed that the request statement goes right there. But you'll find that students sometimes put the request student here, sometimes at the bottom. The nudge would be more, hey, the program executes from top to bottom, so the order matters. Think about where it might be, should go, as opposed to telling them, oh, your request needs to go right there in the middle. Then everything will work for you. Because you need to let them kind of work through this and think so that they get used to thinking about how the program flows. All right, now, I guess that brings us, I pretty much finished task 1. Like I said, task 1's not terribly difficult. None of them are difficult, or it wouldn't be that great of an introduction to programming. Task 2. Now this has a little bit more going on, but it's not terribly difficult. Ask them, what's the next thing you did? What I want my students to think about is the next thing they did was, well, was it even or odd? And then based on that, if it was even, they did something. If it was odd, they did something. So we're going to use the remainder mod function to distinguish between even and odd. Now again, I'll just start with the 84, at least in theory. There we go. And we'll go to Hail 2 because we're in task 2. All right. First, we're just putting this after the stuff we already had because, here was our early code. And then here's the key to this if statement. If remainder n comma 2 equals 0. That is just a nice little command that's inside the 84. Now, I have that listed on my handout. Where it's located is somewhere written in there. They can look through the different commands. All this does is it takes whatever's in the spot that n is, comma, and divides it by the second thing. So n is being divided by 2. If we get 0, well, then we know it's even, because if you divide by 2 and don't get a remainder, it's even. If that's the case, well, we just do n divided by 2 and put it into the end. else, and there's not a lot of else's when you're talking about even and odd. If it's not even, well, then it's odd, and here's what you do. Now, the one thing just to mention, and this is just a little bit about the coding with 84 if you don't have much experience with it. Notice how the if, the then, the else, and the end are all over on the left side. And probably something you may not think about if you haven't done this much is there needs to be an end at the end of this if statement so that the computer knows where the if statement is ended. Now, you'll see that the Nspire code really is almost the same with just a little bit of rearrangement here. And let's see, go to Hail2 here, and I guess I'll have to move this down a little bit so you can see it. The difference being in the Nspire we use mod, but the uses is exactly the same. Mod you're going to see more commonly in programming languages, but the 84's remainder is much more indicative of what it actually does. So there's arguments both ways, but mod just means it's finding the remainder, same thing. The number divided by 2 equals 0, then num. Now notice the small difference here in terms of the way this is set up. The then is out here to the right of the if statement, the conditional statement for the Nspire. Now with Nspire, in some ways you don't have to know as much of where to put these, because if you go into the menu and open this up and put in the if-then statement, it'll put, well, in this case, what it would put in there, it would put the if, the then, the else, and the end if, and then you just fill the stuff in between. Notice it ends with an end if. I mean, that's a small difference. And the then's off to the side, but that's not a big deal. One thing just in terms of things to think about how to help the student through it without giving things away. Students, last time I did this, and it sounds very logical if you think about it, did if it's even, then divide by 2. Then did a separate conditional statement, if it's odd, then divide by 2. That doesn't work, but again, you don't want to say, oh, you just need to use an if-then-else statement, because there's different ways around it. There's some tricky ways. Somebody could put a piecewise function instead of the if-then statement. There's different ways one could get around it that you want to give them the chance to try to figure it out. But anyhow, that pretty much is then the end of task 2. So at this point, you've really done some good things, and I guess I could actually run it. I'm kind of jumping ahead without running. For the Hailstone code, if you want to run on the Nspire, it's Control-R. And brings this up, and this is with the latest software. Then put in whatever you want to. I'm going to put in 55. And see, it took it, is odd, multiplied by 3, and added 1. Now, both on the 84 and the Nspire, if you hit Enter, it'll just reboot this thing. So if I wanted to, I could put 166 and hit Enter, and it'll give the answer. In this case, it divides by 2. You may want to stop your students a little bit and let them play here for a little bit and say, now, would you like this to be automated so you don't have to keep pushing enter, enter, put numbers in? Is a kind of good way to justify task 3, which would be the loop. So let's go to task 3. Now, for task 3, we just, like I said, we want to repeat task 2 over and over again. And I started them by saying, think about which loop you want to use. Now, I did that on purpose because I have, much like I had over there, I have examples. I have the structure of the for loop. I have the structure of the while loop. I have examples off to the side. And I want my students to look at them and think, which one of these fits for what I'm doing? And why does it fit? In worst case scenario, try one and see if it works. And if it doesn't, try the other one. I want them to explore. I want them to think. I want them to, well, I already used the word struggle, but that whole productive struggle thing, we want that going on here. Now, by and large, I found my students do fairly well with the loop. It doesn't seem to give them a whole lot of problems. So, well, let's go to the 84 again. And Hail 3. And you can see, I mean, really it isn't that hard. Just here's the stuff that we had just a moment ago. And all we did is we put the while before all the stuff we had, while n is greater than 1, because we said we wanted to stop at 1. And actually, by and large, my students have done fairly good at getting the n greater than 1 part, or n not equal to 1. And put an end after everything. Same sort of structure as the if-then loop, basically. I mean, you got the end after everything, and then you would run it, and it'd work fine. It's going to be the exact same structure with the Nspire. And so we need to go over till it says Hail 3 eventually. I had some other examples that I jettisoned because it was taking me too long. Apologies. Let's see, can we get the whole thing in? Yeah, we can get it there. And again, there's the beginning of the while. Oops. Well, it helps to actually aim at the right thing. Here's the end of the while. Now, I will say, and I have some of this in the handout, this is going to have some flaws, and so let's run it. And you can add some stuff to make it do better, but just in terms of concepts, this does everything we want. So let's put 12 in. It's not terribly long. The problem is it just says number equals, because that's all we've asked it, and it runs really fast. A little bit of niceties that you could add into this. You could add it just at the end. And here, let me change the view real quick. The computer view. And the same stuff works absolutely 84 and Nspire. First, our display statement. Display number, comma, CT. Okay, that's sort of the same thing we were doing display for, but you can put another comma and put more quotes. In this thing, I just wanted a colon. Then comma number, the number that's been changing all along. Then add something to actually count. I set it equal to 1 to start with, so it comes through the first time it says 1. And then add a little wait command in here. And each of these things is explained also in the handout I give the students. And all I wanted to do was make this so it's more useful if you're trying to explore the Hailstone sequence. And so, like if we run this, and let's just do 12 again. Oh, silly me. Hold on. I just need to take this back down to the handheld size the way I was trying to do it. Control R1. Well, actually, I've already done it. I can just hit enter, except for the fact that I just hit control. But yes, okay, it worked good. 12, enter. Now it goes a little bit slower, and it actually counts for us. Now, that pretty much does everything that we want this program to do. Now, the other things, and I'm not going to even try to do this, but let me just put up what the fourth task is. The fourth task would be to add list. The reason you might want to add a list, and there's a lot of information here, you'd want to add a list because I can kind of then collect all those numbers and I can graph them if I have a list. Or particularly on the 84, you can then go to the list and see what the different elements in the sequence were. Now I have more information here, mainly because lists are a little more confusing. So I try to give my students more of a step up, and I'd probably be more willing to help with the list part than I would in the other part. Still want to do it as little as possible. All right. To wrap this up, I just want to talk a little bit about, to me, where you can use what I've just gone through. First, it really is, if you didn't want to do anything else, you just needed something, programming, coding in and of itself is great. You know, it's a good activity that has some benefits if you did nothing else. You can also use it for review. And I'm going to try to do this a lot more next year. It's one of kind of my goals. But it's to program concepts from earlier in the year. So if you covered a concept, whether it was the slope, I don't know what you might do. Have them, okay, put in 2 points and have it tell you what the slope is. My reasoning for this is I figure if somebody can program something, they understand it. And it's coming at kind of from a different angle. So it's just something I want to start integrating programming much more into my curriculum. And lastly, and this is something Julie's done with it, she uses it to introduce sequences. And you know, because we've done Hailstone sequence, let's carry it over into other sequences. And I think that that's pretty much going to wrap it up for me, and well, probably for Julie too, since she's already finished talking. So thank you. If you have questions, here's our email addresses. Now, obviously, that's also included in the stuff that we have. This is Microsoft Sway that I've been using for the presentation. Apparently, you can't save those, but I can give you a link if you want to look at it. Also, I did put together a PowerPoint that does exactly the same thing. Now, I don't know if anybody wants it, but still, it's there. So you could do the PowerPoint or go there and view this way. And I'm pretty sure when you view it, you could duplicate it, then change it to the way you want it. So that's what I have. And I guess then we will turn it over. Has anybody got questions? Mike, you want to say something, or where do we want to go?
Yeah, thanks so much, Adam. We did have one last question I just saw came in about whether or not you had a class set of these TI-Nspires, or were your students owning their own or Nspires? Like, how's that working in your classroom?
In my particular class, my students buy the Nspire. So just in my situation, it's not a problem for them to buy it. But really a classroom set, if I know Julie has a classroom set of Nspires, and certainly other people have classroom sets of 84s, I think it would work equally well on either platform.
Great, thanks so much.
Mm-hmm. Any other things come in, or?
I think everything has been answered.
So we need to just stop sharing our screen then, huh?
Yep, and then just give me control back and we'll wrap things up.
All right. There you go.
Thanks, Adam. So again, as we begin wrapping things up tonight, if you do have any last-minute questions, please try to get those asked. If there's a chance, I know Adam and Julie will try to get those questions answered. We're really excited that this summer we're going to be bringing a lot of professional development workshops across the United States. More information can be found on our website, education.ti.com, but a lot of them involve things like coding and STEM, things that whether Julie and Adam wanted to tag this as a STEM-specific kind of webinar, but I think there was a lot of STEM that they were doing that was in this webinar in particular. So if you're looking to get more professional development this summer, please feel free to check our website for more information. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events, and we really hope you share your thoughts. We definitely listen to your feedback. To receive a certificate of attendance, go ahead and click that link in the chat window. There's also a link for the documents tonight. Adam and Julie really went out of their way to give you, as Adam and Julie were mentioning, a ton of documents for this webinar. So they really gave you a lot of extra goodies and information that can be found on that documents link. If those links aren't working for any reason, feel free to just hang tight. In a couple days, you'll automatically get a follow-up email, and in that follow-up email will be a link to the recording, a link to the certificate, and a link to the documents. And if you're viewing this on demand, go ahead and click that link, enter that link into your favorite browser to receive your certificate. Thanks so much, Adam and Julie, for everything you shared tonight. I really appreciate it.
Thank you for having us. It was fun.
We enjoyed it. Thanks.
And thanks, everyone, for attending, and we hope to see you back online real soon. Have a great night.